The stones around us hold silent conversations with the stars. Ancient builders did not merely construct shelters, they engineered celestial clocks from rock and shadow, a principle known as time as architecture. Entire civilizations dedicated generations to weaving calendars into their most permanent monuments. But why? You will gain a new understanding of human ingenuity that reshapes everything you thought you knew about the ancient world. How did a pyramid in the desert accurately track the seasons? And what secret does a single beam of light in an Irish tomb reveal about our deepest connection to the cosmos? What does our own relationship with time lose when we forget the sky? For that master stonemason, every stone was a deliberate word in a conversation with the universe. His work was not just about creating a building, it was about anchoring the chaotic flow of human life to the predictable rhythms of the cosmos. He understood that the sun did not just rise, it returned, and his sacred duty was to mark that return with absolute precision. This was a worldview where the sky was a grand, divine blueprint and architecture was its earthly echo. The archaeoastronomer Dr. Giulio Magli explains that for these cultures, building in harmony with the sky was a way to participate in the eternal order of the cosmos. It was a form of active prayer, a ritual that physically connected their community to the powers that governed life, death, and the seasons. This profound belief system answers the most pressing question: why would a civilization with no modern tools dedicate centuries of labor to such an overwhelming task? The answer lies in the perceived stakes. It was not a luxury, but a necessity for cosmic and social stability. The very stones they chose were a testament to this ambition. While wood rots and clay washes away, stone endures. It was the only material permanent enough to capture and hold the fleeting movements of the sun, the moon, and the stars, creating a legacy meant to outlast generations and even empires themselves. This realization forces us to look at the world's most famous ruins with completely new eyes. The grand pyramids, the towering ziggurats, the mysterious circles of standing stones, they were far more than tombs or temples. They were humanity's first sophisticated scientific instruments, designed not just to honor the gods, but to understand them by tracking time itself. And perhaps no single structure embodies this principle more perfectly than a 4,500-year-old tomb on a remote Irish hillside. The Great Pyramid of Giza stands not as a monument to death, but as a silent, ticking engine of cosmic time. Its four sides align with the cardinal directions north, south, east, and west with a precision that would challenge modern engineers. This was no accidental achievement. It was the foundational act of a civilization that built its understanding of order directly into the bedrock, but the alignment goes far beyond the base. Deep within the pyramid, narrow shafts, once mistaken for air vents, pierce through the massive stone blocks on precise trajectories. These were celestial sight lines permanently locked onto specific stars. One such shaft targets Theban, the star that served as the North Pole for the ancient Egyptians. This was their true north, a fixed point in the swirling night sky, and the pyramid captured its light like a stone telescope. During the equinoxes, the interplay of shadow and light across the pyramid's faces created a perfect solar marker, dividing the year with breathtaking accuracy. The genius extends even to the pyramid's very dimensions. The ratio of its base perimeter to its height mirrors the relationship between the Earth's circumference and its radius, suggesting a staggering, encoded knowledge of our planet's scale. Some researchers propose the entire Giza plateau is a mirror of the stars, with the three great pyramids forming a perfect earthly map of Orion's belt. This is not mere stargazing. It is a complex, engineered system designed to track the slow, grand wobble of Earth's axis, known as the precession of the equinoxes and the annual journey of the Sun. The pyramid is a philosophical statement carved in stone, declaring that time and space are one and the same. How could another culture, separated by thousands of miles and years, possibly match such a monumental feat? To find that answer, we must travel from the dry Egyptian desert to the misty green hills of Ireland. While the Great Pyramid charted the stars, the standing stones of Salisbury Plain performed a grand symphony for the sun and moon. Stonehenge rises from the English landscape not as a random collection of boulders, but as a sophisticated Neolithic computer engineered from sarsen and bluestone. Its most famous alignment is the summer solstice sunrise, where the first golden rays of the longest day crest the horizon and spear directly through the monument's heart, framed by the towering heel stone. This single, breathtaking event still draws thousands of modern pilgrims every year, a testament to its enduring power. Yet this was only the opening movement of a far more complex celestial composition. The entire arrangement is a masterwork of interlocking alignments, meticulously designed to also capture the winter solstice sunset and, even more impressively, the subtle, long cycle of the moon. Every 18.6 years, the moon reaches a point in its orbit known as a major lunar standstill, and the architecture of Stonehenge precisely frames this rare event. This was not a simple calendar. It was a machine for predicting the intricate dance between our world and its celestial partners. Archaeologist Mike Parker Pearson's work reveals that Stonehenge was the centerpiece of a vast ritual landscape connected to the nearby Durrington walls by a ceremonial avenue. For the people who built it, tracking these cycles was not an abstract science. It was the very rhythm of their existence, dictating the timing of ceremonies, the movement of herds, and the planting of crops. Their spiritual and agricultural lives were woven together by the predictable motions of the sky. Even the ring of pits known as the Aubrey holes, which circled the monument, may have served as a primitive computer, using movable markers to predict the ominous shadow of a lunar eclipse. The sheer effort involved shouts of its necessity. These builders transported multi-ton bluestones from mountains over 150 miles away, an epic journey that underscores how vital this celestial timekeeping was to their survival and worldview. Stonehenge was a dynamic observatory, its silent stones acting as permanent sightlines on a moving sky. But what happens when this principle of time as architecture is not built from free-standing stones, but is instead carved directly into the living rock of the earth itself? Far from the quarried stones of great monuments, a more intimate form of timekeeping was etched directly into the living rock. Across canyon walls and secluded cliffs, ancient artists transformed stone surfaces into permanent almanacs. A shaman might spend days carefully pecking a spiral pattern or a series of dots, each mark a deliberate record of a lunar phase or the passing of a season. This was not random art, it was a vital, portable calendar, a system of knowledge accessible to the entire community. At the V-V Heritage Site in Arizona, a specific panel of petroglyphs comes alive only during the equinoxes. As the sun reaches its precise position in the sky, beams of light slide across the rock, illuminating certain carvings and casting shadows that connect others, creating a brilliant temporary diagram that shouts, "The seasons are changing." The subjects of these carvings were often the animals themselves, creatures whose annual migrations or mating seasons dictated the rhythm of life. A carved bighorn sheep was not just an image, it was a reminder that the herds would soon be moving to their winter grounds. This was a pictorial almanac, a direct link between the celestial calendar and the earthly one. Experts in ethnoastronomy, a field that blends cultural knowledge with astronomy, study how these symbols align with indigenous oral histories, finding that stories passed down for generations often describe the very astronomical events frozen in the stone. The repetition of symbols like concentric circles likely represents the endless cycle of time itself, or perhaps a specific, momentous event like a supernova that blazed in the ancestors' sky. This practice reveals a profound truth. The human drive to track and understand time was not confined to kings and priests building pyramids. It was a grassroots intellectual endeavor, a shared knowledge system painted and pecked onto communal blackboards of stone. These rock faces taught every person their place within the vast, turning order of the cosmos. This universal language of art and astronomy, born on canyon walls, would find a stunning and unexpected echo in the elaborate carvings of an entirely different civilization waiting across the ocean. Deep in the Yucatan jungle, a pyramid transforms into a serpent before 1,000 watching eyes. The Pyramid of Kukulcan at Chichen Itza is not a static monument, but a living engine of light and shadow, engineered with a precision that stuns modern observers. Its very structure is a mathematical poem dedicated to the solar year. Each of its 4 stairways holds 91 steps, and when you add the single shared platform at the summit, the total is 365. A permanent stone record of our annual journey around the sun. But the true genius of the Maya reveals itself only twice a year during the equinoxes. As the sun sets, the corner of the pyramid's terraces casts a series of triangular shadows down the northern staircase. These shadows connect with stone serpent heads at the base, creating the undulating, brilliant illusion of a massive feathered serpent slithering down from the heavens to the earth. This is the god Kukulcan, made manifest not by magic, but by the impeccable foresight of ancient astronomers and architects. The event was far more than a spectacle. It was a profound reaffirmation of the cosmos in perfect order, a moment when the divine ruler standing before his people was visibly connected to the cyclical power of creation and the descent of a god. The pyramid's design extends its timekeeping duties beyond this single, dramatic event. Its orientation creates unique acoustic phenomena, where a clap echoes back as the chirp of the sacred Quetzal bird, and its corners align with the rising and setting sun on other critical dates in the complex Mayan calendar, which tracked not just solar years, but also the sacred 260-day Teotihuacan round. This was a civilization so consumed with the measurement of time that they calculated a calendar more accurate than the one used in Europe for centuries. Their obsession found its ultimate physical expression in this stone chronicle, a building that was both a clock and a covenant with the gods. From this symphony of light in the Americas, we crossed the globe to a land where the sun was not just marked, but actively harnessed within the walls of a temple. While the pyramids captured the stars, the Egyptians also built machines to capture a king in a beam of sunlight. The great temple of Ramses II at Abu Simbel is a monument of staggering ambition, carved directly into a mountain to face the rising sun. Its architects engineered a phenomenon so precise it occurs only twice a year. On approximately October 22nd and February 22nd, the first rays of the dawn sun spear through the temple entrance, travel over 200 feet through the mountain's heart, and illuminate the statues of the pharaoh and the sun god Ra seated in the deepest sanctuary. The statue of Ptah, the god of darkness, remains deliberately shrouded in shadow. These dates are widely thought to mark the king's birthday and his coronation day. This was the ultimate statement of divine kingship, a ritual written in light, proving that the pharaoh's very life was synchronized with the solar cycle. His power was not just like the sun's, it was physically connected to it. This principle of solar alignment was a cornerstone of Egyptian temple design. At the vast Karnak temple complex, the entire main axis is oriented so that the sun rises directly along it during the winter solstice, flooding the sacred pathway with golden light. The towering obelisks that flanked these temples were not just symbols of power, they functioned as massive, permanent sundials, their long shadows tracing the hours across the temple courtyards with unwavering accuracy. This celestial synchronization extended even into the realm of the dead. Deep within pyramids, narrow shafts aligned with specific stars like Orion or the North Star served as eternal sightlines, guiding the pharaoh's soul to the heavens and providing a stellar clock for the afterlife. The entire civilization operated on a cosmic schedule. The most critical date of the year was the heliacal rising of Sirius, the moment when the star first became visible again just before dawn after a long absence. This event, meticulously observed from temple platforms, heralded the imminent, life-giving flood of the Nile River. The priests did not just watch for this sign, they actively prepared for it, performing rituals within their stone calendars to ensure the gods would renew the world once more. Every temple was an active participant in this cosmology, a stone gear in a celestial machine that linked the divine, the royal, and the agricultural into one harmonious, predictable whole. This was a culture that did not merely observe time, it choreographed its most sacred moments in architecture. From this desert civilization that harnessed the sun's path, we journey to a culture that mastered time by measuring its most fundamental component, the shadow itself. While the Egyptians and Maya carved time into temples, a Maharaja in 18th century India built an entire campus of stone clocks. The Jantar observatories rise from the ground not as mystical monuments, but as a collection of breathtakingly precise scientific instruments, each one engineered from stone and marble on a colossal scale. The most stunning of these is the Samrat Yantra, the supreme instrument. It is a giant triangle, a sundial standing 27 meters tall, whose shadow sweeps across a pair of curved quadrants at its base. Its staggering size is its genius, allowing it to measure time to an accuracy of just 2 seconds, a feat that surpassed the portable brass instruments of its day. This was not a symbolic gesture, it was a working scientific laboratory under the open sky. Another device, the Jai Prakash Yantra, consists of 2 massive, complementary hemispherical bowls sunk into the earth, their surfaces mapped with marble and crossed by wires. An observer would stand inside, tracking the movement of a tiny sunbeam or a specific star across the calibrated surface to pinpoint its exact position in the heavens. The Ram Yantra uses a pair of open cylindrical structures to measure a celestial body's altitude and azimuth, its intricate masonry scales offering readings of remarkable clarity. These structures represent a monumental fusion of knowledge, drawing from Islamic astronomical traditions, Hindu cosmology, and even emerging European scientific principles. Their existence powerfully refutes any outdated notion that non-Western science was less advanced, showcasing instead a highly sophisticated and intensely practical application of time as architecture. The data collected here was vital, used to refine celestial calendars for religious festivals and to standardize civil timekeeping for the entire kingdom. This is a later, yet no less profound, chapter in humanity's long quest to build time directly into the physical world, creating not just a single building, but an entire landscape of observation. What happens when this ambition expands even further, and the calendar is not a building or an observatory, but the very land itself? But what if the calendar was not a single structure, but the entire landscape itself? This leads us to the profound and controversial concept of geomancy, the ancient art of placing structures in harmony with the spiritual and energetic features of the land. Proponents of this idea suggest that our ancestors did not just build isolated monuments, they wove them into a vast, invisible web of alignments. The most famous expression of this is the theory of ley lines, hypothetical straight tracks that supposedly connect ancient sacred sites across great distances, from stone circles and burial mounds to medieval churches built atop older holy ground. Imagine standing atop a Neolithic burial mound in the British countryside on the summer solstice. As you look toward the horizon, you watch the sun set directly behind another distant, man-made hill perfectly framed for just that one evening. This alignment would not be a coincidence but a deliberate marker in a gigantic, open-air calendar, signaling a key date for planting, harvest, or a sacred ceremony. The journey between these sites itself could have been a ritual, a physical walking of a temporal and spiritual path that connected the community to the cycles of the earth and sky. While mainstream archaeology remains deeply skeptical of a single, planned national network of lines, it fully acknowledges that individual sites were meticulously placed to capture specific celestial events. This idea expands our understanding of time as architecture from a single building to an entire ritual geography. We can see this potential on a breathtaking scale in places like the Karnak alignments in France, where thousands of standing stones stretch for miles in parallel rows, possibly charting the movements of the moon. Or consider the vast Nazca lines in Peru, geoglyphs so enormous they can only be seen from the air, depicting animals and geometric shapes. Some researchers propose these, too, functioned as a massive landscape calendar, their alignments pointing to solstice sunrises or the rising of important star groups on the horizon. This perspective completely transforms our view of the ancient world. It suggests that every hill, every river bend, and every prominent stone could have held temporal significance, woven into a holistic worldview where the entire lived environment was a living, breathing cosmic diagram. The city itself became a clock and the land a sacred map to the heavens. The sprawling stone grid of Teotihuacan was a city designed as a cosmic mirror. Every citizen walked streets that were not just pathways but permanent markers of celestial order. The central avenue, known as the Street of the Dead, runs not due north but on a precise 15.5-degree angle east of true north. This was not a surveying error but a deliberate alignment, likely targeting the cyclical rising and setting of the Pleiades star cluster. For the people of Teotihuacan, this star group was deeply sacred, its appearance signaling critical moments in the agricultural and ritual calendar. The entire metropolis was a grand, three-dimensional map of the solar system, with its massive pyramids representing the sun and the moon positioned to reflect cosmic relationships of power and creation. Recent LiDAR technology, which scans the ground with lasers to reveal hidden structures, has shown that the builders did not stop with the city limits. They terraced the surrounding mountains and reshaped the natural basin to enhance these sacred sightlines, turning the entire valley into a single, integrated astronomical instrument. Imagine living in such a place where your daily walk to the market was also a journey along a celestial axis, and the towering pyramids were not just religious centers but permanent, stone witnesses to the turning of the seasons. Your life, your work, and your ceremonies were all synchronized within this vast urban clock. This was time as architecture on its most ambitious scale, a complete harmonization of human existence with the perceived order of the universe. The city was not merely in a location, it was actively aligned with time itself, creating a permanent resonance between the earthly and the divine. From this urban cosmos, we now travel to a site of profound intimacy, where the entire cosmic year was measured by a single, dramatic beam of light piercing a single, dark chamber. Newgrange stands as a silent sentinel in the Boyne Valley, a grass-covered mound older than the pyramids themselves, For most of the year, its interior is a place of profound and perpetual darkness. But for a few precious mornings around the winter solstice, this ancient tomb performs a miracle of stone and light. As the sun crests the distant horizon, a single, narrow beam of gold spears through a unique opening above the entrance known as a roof box. This sliver of light does not simply brighten the doorway, it travels with purpose down the long, 19-meter passageway, finally reaching the deepest central chamber to illuminate its sacred space for just 17 minutes. This was no happy accident of construction. The roof box is a meticulously engineered feature, its dimensions and angle calculated with stunning precision to capture the sun at its very lowest point in the annual sky. The builders needed an intimate, generational knowledge of the solar cycle to choreograph this brief event. In the heart of the darkest days of winter, this was a dramatic symbol of rebirth, a visible promise that the light would always return and life would begin anew. The spirals and diamond shapes carved onto the massive entrance stone and repeated within the chamber itself may be more than mere decoration. They could be a permanent map of the sun's journey or a representation of the cosmos this structure so perfectly captures. That Neolithic farming communities 5,000 years ago could achieve this feat forces us to reconsider what we label as primitive. The communal will required to build Newgrange to move 280,000 tons of stone and earth speaks to a cultural imperative, a shared belief that their very survival depended on marking this cosmic turning point in unshakable stone. This mastery of a single, perfect sunbeam reveals a global language of sacred geometry, where cultures separated by oceans and millennia all sought to trap light itself within their walls. High in the thin air of the Andes, the stone city of Machu Picchu clings to the mountainside, a masterpiece of integration between human will and the raw contours of the earth. The Incas did not simply build on this ridge, they wove their architecture into the very bones of the landscape to create a celestial observatory of breathtaking precision. At its heart stands the Intihuatana stone, the hitching post of the sun. This is no ordinary rock, but a complex granite sculpture carved with stunning accuracy. Its angles and planes functioned as an astronomical clock, and its most dramatic performance occurs during the equinoxes. On those 2 days each year, the sun positions itself perfectly overhead, and the pillar casts no shadow at all. In that moment of suspended light, the Incas believed they had symbolically tied the sun to the earth, preventing their life-giving star from continuing its journey north and abandoning them to darkness and cold. This profound connection was reinforced by other structures across the citadel. The curved wall of the Temple of the Sun features a window that perfectly frames the rising sun on the June solstice, the shortest day of the year in the southern hemisphere. In the Room of the Three Windows, the alignments are thought to mark other significant solar events, turning the entire complex into a multi-faceted instrument for reading the sky. Every observation was intensely practical. The Incas used this celestial data to manage a sophisticated agricultural calendar, determining the exact, critical windows for planting and harvesting at different altitudes in their challenging mountain empire. Their survival in such a vertical world depended on this stone-carved knowledge. The very location of Machu Picchu was a deliberate astronomical choice. Nestled between the sacred peaks of Huayna Picchu and Machu Picchu Mountain, the site offers a 360-degree panoramic view of the horizon. This was essential for their priests, the astronomers of their day, to track the sun's precise path against a backdrop of known mountain notches and skyline features. The Incan understanding of time was a seamless blend of the spiritual and the scientific, a deeply practical philosophy rooted in the undeniable cycles of the sun that sustained their civilization. This harmonious dance between mountain, stone, and sun represents one of humanity's most elegant solutions to the problem of measuring time. From this high-altitude calendar in South America, our journey turns to a very different kind of time-telling artifact, one born not from a mountain citadel but from the sands of the desert. The seafloor yielded a secret that shattered our understanding of ancient technology. In the silent wreckage of a 2,000-year-old Roman ship, divers recovered a lump of corroded bronze and wood that would become known as the Antikythera mechanism. This was not a monument of stone, but a portable cosmos engineered from more than 30 interlocking bronze gears, a device of such complexity that its like would not be seen again for over a millennium. It was an analog computer, a mechanical universe you could hold in your hands. By turning a simple hand crank, an operator could advance the device through time, watching as tiny dials and pointers predicted the future positions of the sun, the moon, and the 5 known planets against a backdrop of the zodiac. It could forecast solar and lunar eclipses with stunning accuracy, and its front face even displayed the timing of the ancient Olympic Games, a cycle tied to the moon. One of its most brilliant functions was tracking the Metonic cycle, a period of 19 solar years after which the phases of the moon align again with the same calendar dates. This device took the grand architectural principles of celestial timekeeping and miniaturized them into a compact, interactive machine. It was a physical model of Greek cosmological philosophy, a universe of perfect, predictable cycles made tangible in gleaming bronze. The very existence of this single, salvaged artifact implies a much wider tradition of lost knowledge. Who built this, and for whom? Was it a one-of-a-kind marvel, or simply the only one that survived from a school of master craftsmen? It forces a humbling realization that our view of technological progress is not a straight line, but a story with missing chapters. This portable cosmos bridges the immense public calendars of stone with the intimate, personal desire to understand and even manipulate celestial time. It proves that the ancient drive to map the heavens was not confined to aligning pyramids, but extended to the creation of the world's first known precision scientific instruments. What other sophisticated machines, what other libraries of geared wisdom, now lie forever lost at the bottom of the sea or crumbled to dust? The Antikythera mechanism stands as a haunting reminder that the greatest structures of the ancient world may not have been made of stone at all, but of ideas, bronze, and genius, most of which we will never recover. These spirals and circles carved in stone are a silent, universal language. They speak of a world where time was not a line but a wheel, forever turning. The perfect, unbroken circle appears from the great stone rings of Europe to the ceremonial calendars of Mesoamerica. It is the ultimate symbol of cyclical time, a concept where seasons repeat, generations are reborn, and the stars return to their starting points in an eternal loop. There is no finality, only the promise of return. This stands in stark contrast to our modern, linear view of time as a one-way journey from birth to death. For our ancestors, the end of a cycle was always the beginning of the next. The spiral, however, adds a new dimension to this ancient philosophy. Etched onto megalithic tombs in Ireland and pecked into canyon walls in the American Southwest, the spiral can represent the sun's coiled path through the sky, the soul's journey through lifetimes, or even the universe itself expanding outward from a single point. At the Gavrini's Passage tomb in France, a single stone chamber is a canvas of breathtaking complexity. Its walls are a dense tapestry of swirling, interlocking spirals. Scholars suggest this is not random decoration, but a sophisticated code, a permanent map of the moon's complex, multi-year cycles. Each curve and wall could mark a phase, an eclipse, or a significant standstill, turning the entire tomb into a stone almanac. By embedding these symbols into their most sacred spaces, ancient cultures did more than track days. They reinforced a core belief that everything in existence was interconnected and recurring. Birth led to death, which led to rebirth. The sun vanished at night only to be reborn at dawn. This symbolic language is a crucial key for us today. When a monument lacks a clear astronomical alignment, these carvings suggest its purpose was still deeply tied to the philosophy of time. They reveal that ancient timekeeping was as much a spiritual endeavor as a practical one, a way to visually express humanity's place within the great, turning cosmos. This profound difference in perception makes us wonder what our own world has lost in the relentless march of the clock. Ancient builders did not see a clock on the wall, they felt a turning in their bones. Their stone calendars were born from a world view where time was a sacred, repeating dance, not a one-way race. For them, the year was a circle of birth, growth, death, and inevitable rebirth, a rhythm echoed in the sun's daily journey and the moon's monthly cycle. This cyclical time was woven into the very fabric of existence. A day was not just a unit of measurement, it was a quality. The spring equinox carried a different spiritual energy than the winter solstice, each demanding its own rituals and activities to maintain cosmic harmony. Building a pyramid that captured the solstice sunrise or a tomb that trapped the midwinter sunbeam was the ultimate act of participation in this divine order. It was a way to anchor their community to the eternal, ensuring their lives moved in sync with the universe itself. This explains the staggering generational effort behind these projects. They were not vanity constructions, they were existential necessities built to preserve the balance of the world. Our modern experience of time is a dramatic departure. Sometime after the widespread adoption of the mechanical clock, time transformed in the human psyche. It became linear, a precious and fleeting resource to be sliced into minutes, managed and optimized. We now speak of spending time, saving time, and wasting time, treating it as a currency. This quantitative view has disconnected us from the qualitative rhythms that guided humanity for thousands of years. We schedule our lives by digital alerts, often unaware of the moon's phase or the sun's precise path across the sky. Revisiting these ancient stone calendars is more than an archaeological exercise. It is a profound critique of our own frantic pace. It suggests that in our pursuit of total efficiency, we may have sacrificed a vital connection to the natural cycles that once gave our lives context and meaning. Their architecture asks us a quiet but urgent question. What have we lost by no longer building our world in harmony with the turning heavens? This fundamental shift in perception is the key that unlocks the true cultural significance of every monument we have explored. It reveals the common thread that binds the pyramid builder, the stone circle engineer, and the rock carver, a shared desire to find their place within the great, eternal wheel of the cosmos. This shared architectural language reveals a stunning intellectual convergence across the ancient world. From the deserts of Egypt to the jungles of Mesoamerica and the highlands of Peru, master builders arrived at the same fundamental principles for trapping time in stone. The first and most universal rule was orientation. Monuments were almost never placed at random. Their foundations were meticulously set to face the cardinal directions, to capture the solstice sunrises, or to frame the rising of a significant star. This was the non-negotiable first step, the act of planting a man-made axis within the perceived divine order of the cosmos. The second principle was the masterful use of light and shadow as a dynamic, moving component. This was not passive observation but active engineering. Think of the sun dagger at Fajada Butte in New Mexico, where a sliver of light pierces a spiral petroglyph only on the solstices. Or recall the engineered beam that illuminates Newgrange's deepest chamber. These cultures were not just building static structures, they were programming annual light shows, using the sun as a celestial actor in a drama written in stone. The third common thread was an insistence on scale and permanence. These were not small, personal sundials. They were colossal undertakings built from the most enduring material available, stone. This was a deliberate choice. A wooden calendar would rot in a generation. A clay tablet could shatter, but a pyramid, a stone circle, or a mountain-carved temple was a legacy. It was a promise to future generations that the cosmic clock would never stop ticking, its mechanisms safe from decay and forgetfulness. This grand scale also served a practical purpose, increasing the precision of the observations by amplifying the movements of shadows and light across vast distances. The fourth principle was the seamless integration with the natural landscape. These builders did not see the land as a blank slate. They saw it as a partner. A distant mountain peak became a permanent foresight for the rising moon. A specific notch on the horizon became a reliable marker for the equinox sunrise. The entire environment was part of the instrument. This holistic approach created a multi-sensory experience that connected the community to the cosmos. The journey to a sacred site for a solstice observance was as much a part of the ritual as the event itself, weaving the celestial cycle into the very geography of their lives. Perhaps the most telling evidence of this shared intellectual endeavor is the recurrence of sacred numbers. The number 365 appears in the steps of Kukulcan's pyramid. The 28-day lunar cycle is encoded in stone circles. The 19-year Metonic cycle, which synchronizes the sun and moon, was not only calculated by the Greeks for the Antikythera mechanism, but was likely understood by the builders of Stonehenge. These are not coincidences. They are the independent discoveries of fundamental astronomical rhythms, the same mathematical truths being read from the same sky by different eyes. This convergence is a powerful reminder of our shared humanity. Separated by oceans and millennia, these cultures all looked up with the same wonder and asked the same questions. Their stone calendars are the common answer, a global testament to the human drive to find our place within the great, turning cosmos. Behind every silent stone clock stood a human mind trained to read its language. These were the astronomer priests, the specialized knowledge keepers who transformed architecture into action. Their role was not merely to observe the sky, but to interpret the messages encoded in the monuments for their entire community. When the sun's beam struck a specific carving or the moon rose between two particular stones, it was these individuals who translated that celestial event into a directive for society. The harvest must begin. The gods require a ceremony. The new year has arrived. Their authority flowed directly from this exclusive ability to mediate between the cosmos and the community, making them indispensable to both spiritual and agricultural life. In ancient Egypt, the precise observation of the heliacal rising of Sirius was a state-level responsibility managed by the temple priesthood. Their vigil on the temple roofs was a matter of survival, as the star's first pre-dawn appearance signaled the imminent, life-giving flood of the Nile. These priests did more than just watch. They maintained generations of meticulous records, allowing them to predict the event with increasing accuracy and prepare the entire civilization for the coming deluge of water and fertility. Similarly, while the direct link is debated, figures like the Druids of later Celtic Europe are emblematic of this tradition, serving as the intellectual class who would have understood the complex lunar and solar alignments of sites like Stonehenge. They were the living memory of the people, the ones who knew which stone shadow marked the day for sowing seeds and which moon phase signaled the time for a great gathering. This specialization was a monumental societal investment. It meant that a segment of the population was freed from farming or building to dedicate their lives to watching, recording, and calculating. This long-term commitment allowed for the refinement of astronomy into a true science. An individual priest might spend his entire lifetime noting a tiny anomaly in a planet's path, an observation he would then pass to his successor, who would add his own data, slowly building a body of knowledge that spanned centuries. The sheer intellectual achievement of predicting an eclipse or calculating the precession of the equinoxes was the result of this cumulative, cross-generational effort, all made possible by a culture that valued celestial knowledge enough to support its full-time practitioners. These ancient scientists complete our understanding of time as architecture. The stones were the hardware, the permanent physical instrument, but the priesthood was the essential software, the living, breathing operating system that ran the machine and translated its output for the world. They bridged the immense, abstract scale of cosmic cycles and the urgent, practical needs of daily survival. Without their constant observation and interpretation, the Great Pyramid was just a tomb and Stonehenge merely a ring of stones. It was the human mind that gave them purpose and power. Their legacy challenges our own relationship with expertise, prompting us to wonder who our modern-day knowledge keepers are and what profound truths we are collectively choosing to preserve for the generations yet to come. The stones themselves whisper of a forgotten mathematics. That breathtaking precision we see in the pyramids and stone circles was not born from lucky guesses, but from a deep, working knowledge of geometry that would not be given formal names for centuries. These builders were practical mathematicians, engineering celestial harmony with tools as simple as a shadow-casting stick and a length of knotted rope. Consider the Great Pyramid's base. Its sides form a near-perfect square, with corners approaching true right angles with an error margin of just a fraction of a degree. To achieve this, the Egyptian surveyors almost certainly used the principle we know as the Pythagorean theorem, creating a perfect 3-4-5 triangle with their knotted ropes to ensure their corners were perfectly square. This was not abstract theory to them, it was a hands-on solution to a monumental problem. They also encoded the constant pi, the ratio of a circle's circumference to its diameter, in the very proportions of the pyramid. The relationship between its base perimeter and its height yields a value incredibly close to 2 times pi. This suggests they understood the concept of squaring the circle, a profound geometric puzzle linking linear and circular motion. Across the sea at Stonehenge, a different kind of geometry was at work. The arrangement of the sarsen stones forms a perfect rectangle and a series of concentric circles, all laid out with meticulous care. The builders used peg and cord geometry, a method where a central stake and a length of rope become a giant compass, to inscribe these perfect rings onto the landscape. They then plotted astronomical triangles between key stones to capture the rising and setting points of the sun and moon. How do you ensure the heel stone is in the exact correct spot to frame the solstice sunrise? You do it by creating a long-term observation point, marking the sun's position over many years, and then using geometric principles to fix that celestial line permanently into the earth with massive stones. This entire process was an act of abstraction. They observed a repeating pattern in the sky, recognized the mathematical relationships governing that pattern, and then physically reconstructed those relationships on the ground. A star's path became a geometric line, a lunar cycle became a measured circle. The stone circle is not just a collection of rocks, it is a frozen equation. The true genius lies in the tools. They had no theodolites or laser levels. Their world was built with gnomons to track shadows, sighting poles to establish straight lines, and those incredibly versatile knotted cords, which could be used to measure, to create angles, and to inscribe perfect circles. This proves a powerful idea that advanced scientific understanding does not always require complex technology. It can emerge from generations of careful observation, accumulated practical knowledge, and the relentless application of simple tools to solve the most profound problems. The legacy of these builders is not just in the stones they left behind, but in the hidden mathematical intelligence those stones represent, a silent testament to the human mind's ability to decode the cosmos. The staggering precision of these stone calendars has always sparked a tantalizing question: could their builders have possessed a wisdom now lost to time? This line of thinking gives rise to captivating theories about a single, advanced civilization, a golden age culture whose sophisticated understanding of the cosmos was scattered across the globe before it vanished. Some look at the uncanny similarities between pyramids on different continents or the mechanical genius of the Antikythera mechanism and wonder if the official timeline of human progress is missing a crucial chapter. The sheer scale of the engineering, aligned with such breathtaking accuracy, can feel inexplicable, leading to more speculative ideas about guidance from beyond our world. These narratives are powerful because they speak to a sense of mystery, a feeling that our past holds grander secrets. Yet, the explanation provided by archaeology, while less fantastical, is in many ways more profound. It asks us to consider a different kind of magic, the cumulative power of the human mind when focused across generations. The Great Pyramid was not a sudden miracle. It was the ultimate expression of an Egyptian architectural tradition that had been refining its craft for centuries. The astronomers of Teotihuacan did not receive their knowledge as a gift. They built it, observation by patient observation, over countless lifetimes. This was a slow, deliberate science where a grandfather's record of a star's position was compared to his grandson's, gradually revealing patterns that spanned longer than a single human life. This incremental process, this relentless dedication to watching and recording, is itself a form of advanced technology. It demonstrates that the greatest resource these cultures possessed was not alien blueprints, but time itself and the intellectual will to use it. Celebrating this human achievement does not diminish the wonder of these sites, it amplifies it. It means that the true mystery is not about who helped us, but about what we are capable of when we work together across generations. The very existence of this debate proves that these ancient stone clocks still hold power, not just as calendars, but as permanent invitations to question, to explore, and to rediscover the immense potential of our own species. A single miscalculation could starve a civilization. The true power of these stone calendars was not merely philosophical, it was profoundly practical, rooted in the most basic human need, food. For the farmers who formed the backbone of every ancient society, the precise timing of the solstice or the equinox was not an abstract event, it was a direct command. Plant the seeds now, the sun has reached its peak and the ground is warm enough for germination, but if you wait too long, the rains will come and ruin the crop. In Egypt, the entire agricultural cycle was a desperate race against the Nile's flood. The appearance of Sirius just before dawn was the starting gun, a celestial warning that the life-giving waters would soon arrive. Without this signal, meticulously observed from temple roofs, society would have descended into chaos, with farmers unable to prepare their fields or store their grain. The stone monuments were the ultimate insurance policy against this disaster. Their alignments provided an unshakable, permanent reference point, a communal guarantee that everyone was working from the same celestial schedule. This direct link to survival explains the staggering collective effort. Why would thousands of people drag multi-ton stones for miles? Because the price of failure was starvation. The calendar was a matter of life and death. But the influence of these cosmic clocks extended far beyond the fields. They structured the entire ritual and social year, creating a shared heartbeat for the community. A specific solar alignment would signal the time for a great religious festival, a market fair where goods were exchanged, or the coronation of a new king whose power was derived from the sun. Even the collection of taxes was often tied to the harvest, which was itself dictated by the sky. In an era before widespread literacy, these structures were the public library of time. A farmer did not need to read hieroglyphs to understand the message of a sunbeam striking a particular carving. He simply had to look. This created a powerful unifying framework. Everyone, from the highest priest to the lowest laborer, operated on the same temporal map. The stone calendars synchronized human activity with the immutable rhythms of nature, reinforcing social order and preventing the kind of disconnection that could fracture a culture. They were the central pillars holding civilization itself together, transforming scattered groups of people into a coordinated, resilient society. The mastery of time was not a luxury of advanced culture. It was the very foundation upon which complex societies were built. Decoding the intention behind a stone alignment is like listening for a single whisper in a storm. This is the core challenge of archaeoastronomy, a field where astronomy, archaeology, and anthropology collide. Its greatest hurdle is proving that a line between a stone and a sunrise was placed there by design, and not by random chance. With countless stones and countless points on the horizon, some alignments are bound to occur accidentally. To overcome this, researchers employ statistical rigor. They do not just look at one promising alignment, they map every single stone and pillar at a site, calculating the probability of so many significant alignments happening by luck alone. They search for patterns, for repeated themes, like multiple stones all pointing to different solstice or lunar standstill positions. This meticulous process separates a true celestial calendar from a collection of rocks that happen to line up. The ground itself has shifted over millennia. Earthquakes, frost heaves, and the slow settling of foundations mean that many monuments are no longer in their original, perfect positions. An alignment that seems slightly off today might have been pinpoint accurate when it was built 4,000 years ago. To solve this, scientists turn to advanced computer modeling. They can digitally wind back the clock, accounting for the precession of the equinoxes, that grand 26,000-year wobble of our planet's axis. This allows them to reconstruct the precise sky our ancestors saw, revealing alignments that have been slowly drifting out of true for centuries. Another profound challenge is avoiding the trap of modern bias. It is tempting to see a complex star chart in a simple pattern of dots, or to impose our scientific understanding onto a symbol that held a purely mythological meaning for its creators. This is where ethnohistory and indigenous knowledge become invaluable. Oral traditions, colonial-era records, and the living practices of descendant communities provide the cultural context that breathes life into the cold geometry. A spiral is not just a shape, it is a story about the sun's journey. A cluster of stars is not just a constellation, it is an ancestor. By weaving together hard data with cultural insight, a clearer picture emerges. The successful case studies, like the undeniable solar and lunar alignments at Stonehenge or the precise equinox light show at Chichen Itza, stand as testaments to this rigorous approach. They show us that these monuments were not built by accident. They were the result of careful, deliberate observation, a legacy of cosmic wisdom patiently rediscovered one aligned stone at a time. These stone calendars were far more than functional tools. They were physical anchors for an entire worldview, a cosmology where the celestial and terrestrial worlds were not separate, but intimately woven together. Each monument served as an axis mundi, a sacred point where heaven and earth met. When the sun's beam pierced the darkness of Newgrange or the serpent of light descended Kukulcan's pyramid, it was not just a solar event. It was a moment of communion, a direct conversation with the gods. Ancient peoples believed that by tracking these cycles with such precision, they were participating in the divine work of maintaining cosmic order. Their rituals timed to these celestial moments were essential acts of sustaining creation itself. The cyclical nature of time reflected a core belief in perpetual death and rebirth. The cosmos did not simply continue, it was renewed each year. The winter solstice was not merely the shortest day, it was a moment of supreme spiritual power when the sun was reborn and the veil between worlds grew thin. A prayer offered then, or a ceremony performed as the solstice light touched an altar, was believed to have maximum efficacy, its power amplified by the architecture itself. This transformed the abstract passage of time into a sacred, communal experience, filled with meaning and profound purpose. To see these structures only as astronomical instruments is to miss their soul. They were the bedrock of a philosophy that saw humanity as an integral part of a living, breathing, and intelligent universe. Every stone was a testament to a deep, animistic relationship with the cosmos, a reminder that the stars were alive and the sun was a conscious force. This spiritual dimension is the most vital lesson these ancient timekeepers hold for our modern, secular world. They challenge our fragmented perception and ask us to remember that we are not separate observers of the cosmos, but active participants within its grand, turning story. That relentless ancient pursuit of accuracy echoes in the silent, hyper-precise ticking of an atomic clock today. While our modern world runs on digital seconds synchronized by satellites, the very framework of our time is a direct inheritance from those early stonemasons and star watchers. Our global standard of a 365-day year divided into 12 months was not invented in a boardroom. It was painstakingly carved into the cultural bedrock of ancient Egypt and Mesopotamia, refined through Roman revisions, and finally calibrated by the Gregorian reform. These civilizations looked to the sky, measured the sun's journey, and gave us the fundamental container for our lives. Even the way we divide a circle into 360-degree springs from their celestial mathematics, a system born from the observation that the sun appears to move about 1 degree along the ecliptic each day. The tools have transformed beyond recognition, from granite obelisks to cesium oscillators, but the underlying units of time remain a gift from the past. This was not merely a technical achievement. That ancient drive to track the year with ever greater precision was fueled by the same human needs that govern our lives today, the fundamental requirements for societal coordination, for long-term planning, and for a deep, philosophical understanding of our place in the cosmos. We see the legacy of time as architecture all around us, not just in our calendars but in the physical world. A simple sundial in a garden is a miniature Stonehenge, using a shadow to mark the sun's passage. The great public clocks on town halls and church towers are the spiritual descendants of those monolithic calendars, still synchronizing the daily rhythm of a community. This principle even finds new life in modern sustainable design, where architects use precise solar orientation and clever shading to harness the sun's energy, turning entire buildings into efficient, modern-day sun clocks. To study these ancient systems is to trace the roots of our own consciousness. It grants us a powerful perspective on our frantic relationship with the quantified minute, reminding us that this vast, global network of precise time is the culmination of a quest that began when the first human pushed a stone upright to mark a solstice shadow. That long, unbroken arc of history connects the silicon chip in your smartphone directly to the intellect of the master builder who first dared to build a calendar from the living rock. Every aligned stone we uncover seems to raise two new, deeper questions. The true scale of this ancient science is still coming into focus, and its lingering mysteries promise to redefine our past. Take the enigmatic T-shaped pillars of Göbekli Tepe, a site so old it predates Stonehenge by 6,000 years. The intricate animal carvings covering these pillars are not random art. Some researchers propose they form a symbolic code, a potentially 11,000-year-old calendar system that tracked the movements of stars or even recorded a catastrophic comet impact. If true, this would push back the dawn of structured timekeeping to an almost unbelievable era, forcing us to rewrite the first chapter of human civilization. At sites we think we know well, like Machu Picchu, new technologies are revealing secrets the naked eye could never see. High-resolution three-dimensional laser scanning, or LiDAR, can map every contour of a ruin and the surrounding landscape with millimeter precision, uncovering faint architectural features and subtle alignments that have been hidden for centuries. This same technology is peering through the dense canopy of jungles in Cambodia, suggesting the vast urban sprawl of Angkor Wat was laid out with celestial principles that we are only beginning to comprehend. The potential for discovery is staggering. How many more of these stone clocks lie buried beneath desert sands or tangled roots, completely unknown to us? The search is no longer confined to the ground. Satellite imagery and drones survey vast areas, identifying promising anthropogenic patterns invisible from the surface. Perhaps the most revolutionary tool is artificial intelligence. By feeding an AI thousands of data points from known archaeological sites, we can task it with finding patterns and alignments across continents that a single human researcher could never connect. This digital assistant might one day identify a grand, hidden network of solar and lunar alignments linking sites across the globe, revealing a shared architectural language we can currently only guess at. But the key to unlocking these mysteries may not lie in new technology alone. It may reside in a deeper, more respectful engagement with indigenous knowledge systems. We are learning to listen. The oral histories of First Nations peoples in Australia, for instance, describe landscapes that function as elaborate calendars, where the rising of a star group against a specific rock formation signals the arrival of a particular season or the readiness of a food source. This teaches us that a calendar does not always need carved glyphs or towering pyramids. Sometimes the entire living world is the instrument. Each answered question peels back a layer, revealing our ancestors to be even more ingenious, more connected, and more scientifically advanced than we previously believed. The conversation with these ancient builders is not a monologue from the past. It is a dynamic, ongoing dialogue, and the next great revelation could be waiting in the next satellite survey, the next laser scan, or the next story shared by an elder. The next chapter in this story is being written now, and it promises to be the most astonishing one yet. Our journey through these stone calendars uncovers a civilization of profound philosophers and scientists, people who understood time as the very fabric of the cosmos. They were not merely marking days, they were etching eternity itself into rock, driven by a universal human yearning to synchronize our fleeting lives with the grand cosmic dance. These monuments are far more than silent ruins. They are permanent invitations for us to look up, to wonder, and to remember our place within a vast, rhythmic, and intelligible universe. The true revelation is the staggering sophistication of pre-modern science, a holistic worldview that wove the practical needs of farming, the spiritual longing for connection, and the cosmic order into one seamless whole. As we navigate our own frantic, digital age, These ancient clocks whisper a powerful reminder to pause and reconnect with the natural cycles that have always guided life on this planet. I urge you to look at the oldest stones in your own landscape with fresh curiosity. What celestial secrets might that weathered obelisk or that local standing stone hold? If this exploration of humanity's cosmic architecture has captivated you, please subscribe for more journeys into the mysteries of our shared past. Let me know in the comments which of these ancient calendar marvels intrigues you the most.